Okay. Now we're going to start working on more complex models for forecasting. Okay. So again, these are the 4 different scenarios that we have to look at. A case where there is only random fluctuations, okay, no trend, no seasonality. Then we can use naive model, and there are 2 other models that we can look at. One is called moving average. 3. We can look at 3: moving average, weighted moving average, and exponential smoothing. Now, if the next case we will look at is this one, where there is trend and random variation. No seasonality, but there is trend. So we have trend and random variation. So then we have an exponential smoothing model that includes trend. And then we can also use regression analysis to project the trend. So there are 2 different methods that we will look at for this case. And then we'll look at this case of seasonal variation. So again, we'll be using averaging method to find the seasonal ratios. And then finally, we will look at the case of trend and seasonality. And here is where we will be looking at the multiplicative model and the additive model. We will use a method called decomposition method for multiplicative case, and we will use regression analysis with dummy variables for the additive case. Okay. Moving average is simply an average of certain number of previous periods. So you come up with a number n period. So n can be if 2 or 3. If n is 1, then that is naive. Okay. So you can say, all right, I want to use 2 period moving average, or 3 period moving average, or 4 period moving average. Okay. So these are some of the possibilities. Okay. And then how do you select how many periods you should use? Okay, n equal to 2 or 3 or 4 or 5 or 6 or what? And that's where your forecast accuracy comes in. So for each of those cases, you'll compute the forecast accuracies and then you'll compare. So let's look at this example here. Okay, Wallace Garden Supply example, and the numbers are here, the actual shed sales. Okay, so we have actual sales starting from January through December. Okay. And we want to use moving average. So usually when you start working problems out in a time series, the first thing to do is to plot the time series and then see what it looks like. Okay. So let's highlight that. So to insert, and then if you do that, then you see you have a plot, and this plot is called a time series plot. So let's look at, make sure that everything is fine here. So X value comes from B, Y value comes from C, and that's good. So axis title, so sheds sold, and the x-axis is month. Okay. And it's hard to tell what kind of pattern there is. It looks like there is a trend going up through month 8 and then it's coming back down. So there is probably seasonal variability, and there could be some trend as well. But for the moment, let's for the purpose of illustration, so let's say there is only random variation and we want to use moving average to come up with the forecast. Because if all you want is the forecast for January, then if you're going to use moving average of n equal to 3, then the forecast will simply be that. Okay, you look at the most recent n periods and find the average. Okay. Now if you want to use MA4, then that would be the most recent 4 periods. That will be your forecast. Okay. Now if you want to use 5 periods, then you look at the most recent 5 periods, find the average, and that will be your forecast. For the moment, let's not worry about decimal places. Okay. Now, which one is likely to be more accurate among these three? So that's where your MAD is helpful. And for us to find the MAD, you have to go back and compute the forecast for the historical data, and then you can compute the error values. Once you have the error values, okay, so then you can compute all the forecast accuracy measures. And for that, we have to set up the forecast for the historical data. And for MA3, you need the first time period for which you have a complete 3 values for the MA3 is this. So the first forecast that we can compute is for April. So April is what? April is the first month for which we have all 3 sales that we need. Okay, again, let's not worry about the decimal places for now. We're just illustrating how this thing works. Okay, so now you copy that. So now we have moving average forecast for April through December. Okay. The forecast using moving average 4 periods, well, the first month for which 4 previous sales are available is May. So MA4 can only start from May. Okay, again, don't worry about the decimal places. All right, format, so it'll be consistent. And MA5, the first forecast that you can compute is for June. All right. Okay, let's put the border back. All right, so now we can compute the error. Okay, so this is actual value. Okay, now I'm going to use relative addresses so we can copy this formula for MA4 and MA5. For MA4 and MA5, the actual value must still come from column C, but as you go down, the row should change, and therefore the absolute reference should go to the column. Okay, so like that. So press F4 and then you'll get that. All right, so now let's and then minus the forecast. Okay. Now we want absolute error, so let's put the absolute function around it. Okay, I'll copy that down. All right. So for MA4, since the first forecast is only from May, copy just that. So copy that, and because we have absolute referenced column C, so your errors will be properly computed. And for MA5, it has to start only from June. Okay. So now we can compute the average. Okay. Now this can be copied because the blank will not affect the average. Okay, but if it is not a blank, then it will affect the average. So the blank will be omitted, in other words. So it will add up all these values and count only the non-blank values for the denominator. Okay, so now you see there is a basis for comparing these forecasts. Okay, from the computations, a 3-period moving average has the smallest MAD. Okay, we may still want to try the other methods like the weighted average and exponential smoothing, but among the moving averages, okay, 3-period moving average gives you smaller MAD. Okay, so usually in terms of periodicity, if you include very few periods, then the immediate fluctuations will be very quickly reflected in your forecast. So it will be more responsive to immediate changes in sales value. But if you have a large value for n, so that is, if you take lot of previous historical data in your average, that means the immediate changes will get averaged out by a larger number of actual sales. So the forecast will be more steady. Okay. So there is stability and responsiveness. Larger n will be less responsive, but it will be more stable forecast, and smaller n will give you more responsive forecast, but it will be less stable.